In this work, we introduce unsupervised segmentation incorporating shape prior via generative adversarial networks. We tackle the task of object segmentation, which by partitions an image into regions of interest and background regions. The quality of object segmentation is often degraded by bias fields and occlusions. Another challenge is that the modern supervised approaches require expensive manual annotations that are rarely available, leading to the need for unsupervised methods. Recent unsupervised approaches borrow the generative adversarial framework to construct a distribution of composite images of foreground and background, and induce it to contain the appearance and geometric properties of the original input image distribution. However, learning the distribution that encompasses both properties is difficult due to the enormous dimensionality and variations. We propose an unsupervised segmentation algorithm consisting of three constituent parts: unsupervised intrinsic decomposition, unsupervised segmentation exploiting intensity values, and GAN-based shape incorporation mechanism that imposes geometric constraints on the segmenting function, while reducing the complexity of the distribution to be learned. The three components of our method are integrated and work in one framework. For the intrinsic image decomposition, we consider an image formation model using an additive noise with a multiplicative bias field. The loss function used to train the intrinsic decomposition model is derived from the image model. The obtained intrinsic representation is fed into the segmentation network that directly outputs segmenting function phi using piecewise smooth Monfortian model that segments images based on intensity values. The segmenting function and its associated estimates for the foreground and the background of segmenting region are represented by the separate outputs of the neural network for the segmentation. We also propose to impose shape information about a region of interest into its segmentation by exploiting prior knowledge of segmenting function using the generative adversarial network. We extend the probability of segmenting function to the joint probability with an additional variable psi that is an explicit shape. This process imposes an implicit regularization on the segmenting function. The shape to be used as the prior knowledge is represented in the form of binary images. The GAN objective function is used to obtain the optimal model parameters for the discriminator network and the segmentation network with an adversarial training scheme, imposing the shape constraints on the segmenting function. In the evaluation with synthetic dataset, the segmentation results from the intrinsic images are better across all the variations in the bias fields, whereas the segmentation quality on the original ones deteriorates as the standard deviation of the bias field increases. Also, our algorithm for imposing shape constraints is shown to be robust to the varying degrees of occlusions. The evaluation results with different methods clarify that using intrinsic representation and shape priors yields the best results across data of different configurations. In the evaluation with Elson dataset, our full model provides the best fitting segmentation results, as shown in the examples of 4 different categories. The quantitative results also demonstrate that our full model outperforms other state-of-the-art unsupervised methods under comparison. Thank you for listening.